boys. Okay, so you have a styrofoam cup with 50 grams of water in it. Okay, so you can kind of picture what I have here. I have a my cup, styrofoam, because styrofoam's a pretty good insulator. It's got about 50 grams of water in it. Okay, 50 grams. That water is at 10 degrees Celsius. I'm going to add an iron ball. This is my iron ball. Okay, my iron ball weighs 50 grams as well, but it's much smaller because it's much more dense. Okay, we're going to add it to that, and the ball has a much higher temperature, 90 degrees Celsius. Okay, we want to know what the final temperature of the water is after we mix them together. All right, so this type of problem I typically set up like this. I know that all of the heat lost by one thing is gained by the other. Okay? So the heat of my iron ball is gained by the mixture or by the water. So the final temperature will end up being kind of a mixture of the two. Okay? So here's the things I know. The mass of water is equal to 50. The temperature of the water. Now, this is temperature initial. Okay? So temperature of the initial temperature of the water is 10 degrees Celsius. Now, we don't need to do Kelvin for these. These are the only problems that you don't need to convert to Kelvin because we're doing change in temperature. So change in temperature Celsius is the same as change in temperature Kelvin. Okay? So now we're going to add the mass of an iron ball. This iron ball also weighs 50, much more dense. Okay? So it doesn't take up as much space. And my temperature of the iron ball is 90 degrees Celsius. Okay? My initial iron temperature. Okay, so we're going to mix those together. So do you remember I knew Q equals SM delta T? And if I put the negative side, the iron, equal to the SM delta T of the water, the energy that's gained. So that's the first law of conservation, or the first law of thermodynamics. All matter and energy is conserved, right? Okay, so we're not creating any new energy. All right, so this delta T I got to break up into temperature final minus temperature initial, and then we're going to solve for temperature final. Okay, so here's what I know. Negative. This whole side, really. Okay. S for the iron, because this is the negative side. Okay, so iron is 0.45. Now, these are probably the only problems I leave out the units. The units kind of get confusing because you're adding and then dividing, and okay. So normally I wouldn't tell you to leave out the units, but I think in this case, you should. Okay, so this is 50 grams. And then change the temperature. Temperature is temperature final minus temperature initial. Okay, so temperature final is what we're solving for, minus the temperature initial of the iron. Okay, that is 90. So I have this side, okay, is equal to this side. Now this side's going to be my water. The specific heat of water is extremely high, 4.184. Okay? One of the unique things about water. The mass of water was 50. And temperature final, which we're solving for, minus temperature initial, the water is at 10 degrees. Okay? So what we're going to do is multiply it out. And then I'm going to combine like terms and then divide so that I can get what TF is. And that will be the final temperature of the iron ball and final temperature of the water. So not just one or the other. Okay? So 2.45 times 50 is 22.5, so I have negative 22.5 TF. Okay. And then I have plus 2025. Okay, so that is 22.5 times 90. I had a negative and a negative. Okay, so equals. Then I have 209 TF. And then I have minus 2090. Okay? So this side is negative 2090, the other side's positive 2025 at this point. Okay? So now I'm basically going to combine like terms. Okay? So I'm going to add 2090 to my 2025. Gives me 4,115. Okay? And on the other side, I got to add 22.5 to both sides. Giving me 231.5 TFs. Okay? So now if I would take my 4115 divided by 231, gives me 17.77, 17.78, so we'll call that 17.8 for the final temperature of the mixture.